Hi, in this video we will learn how to do some basic operations on vectors. Specifically, we will learn about scalar multiplication, how to multiply a number to vector, vector addition, vector subtraction. So let me start with scalar multiplication. By scalar multiplication, we mean we have a constant. If C is a scalar means that is a real number, any number. If C is a scalar and U a vector, then we can multiply that scalar to U. We call the scalar multiple of U by C. Then the scalar multiple of U by C, we denote it by CU, is a vector given by, well, CU, if U is a vector, two-dimensional vector, so if U is something like U1, U2, what we do is that we multiply C to first component, C to the second component. And the same thing is true when you have three components, meaning that, well, I multiply C to the first component, C to the second component, and C to the third component. That is when U is a three-dimensional vector. Well, this is algebraically what happens. So multiplication of a scalar to vector is just multiply C to all the components of the vector. But what about the geometric meaning of this thing? So the geometric meaning of scalar multiplication. Well, see, if U is a vector, CU is going to be another vector. But what will be different is that when C is a positive number or when C is a negative number. If C is a positive number, and this is U, then CU is going to be a vector which has the same direction. So CU has same direction, but its length is C times the length of U. So the length of CU is C times length of U. However, if U is C is a negative number, and this is, say, U, then again the length of the CU is going to be absolute value of C times length of U, but the direction of the CU is going to be exactly the opposite direction. So it will have, in this case, opposite direction, and its length, you remember that length is always positive. I cannot say its length is C times U. C is a negative number. I have to multiply it by another C. So that would give us the length. So that is what scalar multiplication in geometric picture mean. That's the first operation. The second important operation is vector addition. So we have two vectors. Let u and v be two vectors. Then sum of u and v is a vector we denote it by u1 sum plus v, which is given by, okay, how do we find u plus v? This is going to be a vector. Algebraically, I have to tell you what are the components of u plus v. If we are in two dimension, it means that u has only two components. So u has only two components, so it will be u1, u2, and v has two components, v1, v2. Then the sum is going to have again two components. The first component is sum of the first components of u and v, and the second component is sum of the second components. In the three-dimensional case, also the same happens. u1 plus v1 is the first component, u2 plus v2 is the second component, and u3 plus v3 is the third component. This is when we have vectors with three components. We can only add vectors with two components to two components and three components to three components. That's what will happen in this case. Well, okay, that's nice. This is algebraically what will happen. How about geometrically, there's very nice meaning for u plus v. So if this is u, this is v, doesn't matter in 2-dimension or 3-dimension, any two vectors anywhere you give me. U plus v is basically you form a parallelogram using u and v, and then u plus v is the vector which is given by the diagonal of that parallelogram starting from the origin. So that's how you find u plus v in the geometric picture. Well, okay, so that's the second thing. Again, you add the components. The third thing, that third operation we want to learn is that a vector subtraction. So the vector of u and v are given. Two vectors, and then u minus v, the difference, is a vector given by, well, what I can do is that, well, exactly same thing as before. U minus v is, well, if it is 2-dimensional case, you do subtract the first component of v from u, so u1 minus v1 and u2 minus v2. If it is 3-dimensional, you have u1 minus v1, u2 minus v2, and u3 minus v3. 3. This is in two-dimensional, this is in three-dimensional case. In all the above cases, what you see is that, note, in all the above cases, there is one important thing you have to keep in mind. Doesn't matter how many components you have, the basic operations, the above vector operations are done. The word is component wise, meaning that if you're adding two vectors, you just add the corresponding components and put them in the corresponding places. If you're subtracting, you just subtract the corresponding components and put them in the corresponding places. And if you're multiplying a scalar to a vector, you just multiply that scalar to every given component and then put in the corresponding place. That's what is important to know, and I want you to keep this really in mind, component wise. We will get back to this very soon. There is one more thing, another thing here is that I just wanted to write negative of a vector. So negative of a vector is a vector, let U be a vector, then its negative, we denote it by negative U, is a vector. So if anyone wants to describe a vector geometrically, you have to tell me two things. What is the direction? What is the length? Negative vector has with the opposite direction as vector U and the same length as U. So in other words, if U is this vector here, negative U will have exactly same length, but exactly in the opposite direction. This time, this is the geometric part, but as you have seen, we work with the algebraic interpretation. So algebraically means that what happens to the components. Well, to the components, this is what will happen. Negative of U is multiply negative to all the components of U. Doesn't matter if U is a vector with two components or a vector with three components. So this is when U has only two components, and this is when vector has three components. With this thing in hand, well, you just keep that negative means it is a vector in the opposite direction with the same length. But with what is written there, you can easily see that when someone says U minus V, what basically we mean is we are adding U to the negative vector of V. And well, that means that you're doing something in the components as we have seen in the above work. So you subtract the corresponding components, and put them in the corresponding spots. So these three operations, scalar multiplication, vector addition, vector subtraction, are the basic operations of the vector, and you have to understand geometric meaning of each one, and so on.